I much rather watch it as a video than actually.
Yeah, because Mr. Coons makes us log in, and it's such a thing.
It's super awkward because you're just like there.
Yeah, you're just doing your homework there.
For me,
You have to stay.
remember, you are
You have to log in and tell them that you're done, and then you get on. That takes
Kind of funny.
So, good morning, ladies and gentlemen. Recording has started. I just feel like that's the easiest way is this. Okay. Before we get into it, yesterday I got so excited to give you your first problem bank that we actually didn't finish section 2. So we're gonna do that and then get into our last section. Okay. So after today, we're done with chapter 1. Again, chapter 1 is a quickie quiz. See, I can't even talk today. A quickie chapter. Like I said, I want to talk to you about next week. Okay, since this is your last time in the building this week, I want to give you a heads up. Okay, so Monday is a holiday. Okay, but in order for us to not lose as much time as we've already lost in terms of this, okay, I can already tell you right now that how things are going, we are not going to cover everything I want to this year. Okay, unless it changes. Okay, unless either we're all in or all online. Because those of you, we got to get labs in, right? We got to do hands-on labs, and you're only here 2 times a week. Okay, testing wise, I want in-person tests. I don't want to do online tests. I can do online quizzes all day. Okay, but I want to do in-person tests. Okay. So with that being said, next week you have scheduled your first test. Okay. So kind of you'll see this when I send it out. But next week's schedule is this. On Monday, I'm going to send out an assignment, short assignment. Okay. Conversions. That's all it is. All right. Tuesday, I'm going to give you another just kind of addition to the practice, and it's going to be time for you to review for your test. Okay. Now, if I didn't say it last week, I meant to, but when it comes to reviewing for tests in this class, it's typically I don't do any kind of review games or anything like that. I give you the practice stuff. I need you to, because the chapters are so short, you should be able to get in there. If there's a multiple choice test, look at the stuff, go through your book. If it's a math test or anytime there's math, I will give you either the solutions or at least the answers. Okay. So then you got to go back and try to work them out so that your answers match. Okay. With that being said, so right now we're on Tuesday. Review for your test, and I'm going to give you some additional practice. And I might even let you work with partners, just as long as we stay separated, okay, on that. Wednesday of next week is your test. You with me here? Wednesday is your test. I typically like to do labs before tests, but my hands are tied on this, okay? I just can't, obviously. So what's going to happen is you're going to take your test Wednesday, and then the B group's going to do their test on Thursday, their first day here. And then on Friday, you're going to read over the lab on next Thursday, get ready to see what you need to do so we can make it a 1-day thing. And then on Friday, I'm going to have you do a section of notes of our next chapter. Okay? B group will do the lab on Friday. And they will then also have to do notes on that following Monday. That way, on Tuesday, everybody is at the same spot. Okay? So we're talking like a week and a half away. Or almost 2 weeks, actually. So by that time, it's like this. So as you can see, trying to get everything moved into place is like a chess game. Okay? Because I cannot have one group get further or farther ahead or farther behind than the other. And because of only the 2 days a week and the necessity to get hands-on stuff in here, that's just kind of what we have to do. Okay? So unless anything changes, then that's just how it's going to be. And I wish I could do something about it, but some days you'll be taking the test second. It'll work out. It's just a bummer that, like I said, we won't get to do as much as I want to this year as of now. But we're rolling with it. Okay. Anyway, you'll get that rundown again over the weekend. So if you've already got the test review, so if you want to start well in advance of studying, then by all means, be my guest. Okay. So at the start of the class, I mentioned that I got a little excited about giving you your first problem bank. Now that I have done the problem bank a new way to start off this year, there was a technical glitch that someone pointed out to me. I think it was in the B group. And I think I fixed it because that's the only person who commented on it. Were you able to put letters in the response and numbers?
Yeah.
Okay. For some reason,
I wasn't able to.
did you do it early?
I did it early, yeah.
Okay. And I fixed it later in the day yesterday. Okay. And that's fine. If you couldn't do it, it was on my end, so don't worry about it. Because I think that labels are a big deal, and if you couldn't do it, obviously there's some issue. The form that I typed everything into decided that it wanted to automatically put in a random thing in there that 8 out of the 10 of them had. So you probably noticed that out of 2 of them you could, right?
Yeah.
The other 8 had this thing on there. So when I went back in there, I was like, why is this even here? So I was able to kind of cancel those out, and then I guess it worked fine after that. So, yeah, learning experience. But anyway, was it easy? Was it the same as you'd expect? Was it more difficult to do it that way? What are some insights into that? Who thought that it'd be okay to continue that way? Okay. Would you be opposed if I went to the paper version?
Yes.
You like it online? Okay, that's fine. And I don't have to really recreate these problem banks because they're already there. It's just the part that takes the longest on here is Google and formatting with that stuff. As you saw with exponential notation, they're not necessarily user-friendly when it comes to that, but I can make it work. As long as you're able to read it and get the gist of it, then I'll continue to do that, okay? And then you can yes. Cha?
So there was one where the units was like kilometers maybe.
Uh-huh.
And then there's actually kilometers squared.
Uh-huh.
And so we didn't remove it from the notes. So should I have multiplied the 2 by whatever I had for my exponent, like 10 or 1 or whatever I had?
So anytime you're doing something like that, and that was every once in a while you'll get tossed in one of those to kind of make you think, because you've probably done one similar in the past, okay? But anytime you have something like a unit is squared or cubed or whatever, okay? The conversion factor that you're going to, you need to square that entire conversion factor, okay? Does that make sense? So let's say if you are going to, I'm gonna try to do this so those at home can see, which I doubt. Right. Anyway, I'll do it up here. Let's say you've got 2.0 centimeters squared, and you need to go to meters squared, right? What you would do is, on the conversion factor, what's a conversion factor for centimeters to meters? 100, okay? 100 centimeters for 1 meter? You have to square it like that. Because when you do that, all your units get squared because you can't cancel that out unless it's a like unit, right? So then once you square this, those can cancel out. Don't forget to also square the 100, all that stuff. Okay? Yeah, and that would be because you're talking about area at that point. So you're talking about a wider piece of measurement. You get, yep. Mm-hmm. Because again, you're going from small to big, so your numbers are going to essentially shrink. You know what I mean?
Yeah,
Okay.
so I couldn't know if I had the right to start.
That's okay. And again, as I was telling Gage here, this first one, because it is a new format, I'm going to look at it as a completion. Okay. And then that's when I wanted to get some feedback from you, see how well you liked it. Okay. So don't worry about it if you kind of had a mistake on this one. Okay. This one is again new format, getting the brain working again, all that good stuff. Okay. But yeah, it's a good question because. Okay. Let's get back into it.
Sign. Supposed to be done.
It's a sign that it's so excited that it wants to continue learning. All right. Section 2. So if you want to have your notes out. Oh, this is already starting to hurt my nose. Section 2 started to end on the idea of accuracy and precision. Again, this is not the first time that we've talked about this. We talked about this in Honors Chem, but we also need to make the distinction between the two again, okay? And accuracy is a description of how close the measurement is to the accepted or correct value, there it is, of the quantity being measured. Precision is the degree of exactness of a measurement. And I actually don't like necessarily that definition. Kind of a mess here. Of precision. Because really what precision is how close are your measurements consistently. After each trial that you run of an experiment, how close in proximity of the measured values are all the measurements? Okay? Are they all very similar, or are they scattered all over the place? Okay? Obviously, it's a better sign to see all of them closer together, but we don't always see that. And in our measurements, we have a certain level of what's called uncertainty. It's a numeric measure of confidence in measurement. And so the lower our uncertainty is in our experiment, the greater the confidence. Okay? And that uncertainty comes from what type of equipment we're actually using to measure the object or measure the distance, whatever it is. Okay? So we'll talk about that uncertainty and its importance here in just a moment. But here I have a bullseye. Okay? Let's look at this here. If I were to shoot 3 arrows, not 2, 3. Anybody know what that movie's kind of based off, or that line's based off of? Very good, Monty Python. Excellent. A wonderful movie, by the way. So we need to talk about accuracy and precision. How would you describe that in terms of accuracy and precision? What about accuracy? Bad. Yes. Why is it bad? It's not close to the center, which the center is the accepted value. What about precision? Precision? No. They're not grouped. So it's not precise at all either. Okay? What about accuracy? Could be better, but pretty good, right? What about precision? Pretty good precision. They're all pretty grouped here. Okay? What about how would you describe that? Good precision, bad accuracy. Very good. So there you go. You got an idea of that. And so a lot of times you are able to notice that when you graph it. When you graph your data, you'll be able to see, a lot of times you'll really be able to see its precision. Okay? But oftentimes you have to resort to a known value, much like what we saw yesterday, in terms of how we used to measure a meter and how we do it now and all that stuff. Okay? All right. Here we go, folks. Sig fig time. Yes, there is a reason we have sig figs. I completely understand it. Okay? But, it all comes off of your precision. Okay? And it comes off of how we interpret your results. Because if we were to measure the area of this room, let's say we measured the length of this front wall with a little 6-inch ruler. Okay? 6-inch ruler, measured this whole wall using that. Next, we measured this wall, the Chuck Norris wall, with a laser instrument, very accurate laser instrument. And we use those two pieces of equipment to measure the area. Which one do you think we'd have the most uncertainty in terms of the actual value? The ruler. So even though we used the laser on the Chuck Norris wall, we can only report our precision, our measurements, in terms of the uncertainty of the ruler. Your weakest link, your weakest measuring device is how you report your answer. Okay? That's where sig figs comes in. Okay? It's a measure of the certain numbers plus one additional uncertain, or kind of estimate. Okay? Now, you know that there are rules. We'll talk about those here in a second. Okay? This ruler, this example here, we've got centimeters and half centimeters. And we can see that when we want to measure the length in here, we see that it goes just beyond the eighth, the 8 mark here, but that'd be actually 18 based off the top picture. But that's pretty much our last certain number, the 18. The tip of that pencil lies somewhere between the 18 and a half and the 18. So that decimal value is going to be uncertain. So we can only report it to one decimal spot. I would say if you were to look at that, I'd say 18.3 is probably what I'd go with. Maybe 18.4. But that 0.3 or 0.4, that's our level of uncertainty. Okay? So here are the rules as stated in our textbook. Again, not all are my favorite. I'll kind of tell you how we're going to do this. Okay, these I kind of agree with. Really, it all comes down to kind of the whole mathematical use of them. So, zeros between other non-zero digits are significant. So, 50.3, that zero is significant. So there are 3 sig figs there. Okay, 3.0025, there are 5 sig figs there. So yes, we follow that rule. Second rule here, zeros in front of non-zero digits are not significant. Because we've used that before. 0.892. That 0 is not significant. So just 0.892 only has 3 sig figs. Rule number 3. Zeros that are at the end of a number and also to the right of a decimal are significant. The almighty decimal. Okay? As long as there are zeros to the right of a decimal, no matter if they are between numbers or not, creates a significant value. 57.00. Because of that mighty decimal, 4 sig figs. Okay? Now, number 4 kind of gets a little weird. I love this. This is why people are driven nuts by sig figs. Rule number 4. I'll tell you how I feel about this one. Zeros at the end of a number, but to the left of a decimal, are significant if they have been measured or are the first estimated digit. Otherwise, they are not significant. In this book, they will be treated as not significant. However, some books place a bar over a 0 at the end of a number to indicate that it is significant. This textbook will use scientific notation for these cases. Exactly. That look right there. What? Exactly. Doesn't make sense. That is why this statement right here in number 4 is why people don't like sig figs. In this book, they will be treated as not significant. However, some books will say they are significant, and they're going to place a bar over it to say, yes, we are significant. So which is it? Yes or no? Well, I think the book actually makes it simpler. Okay? The book's method is probably the easier method. Okay? So for us, if we see a number like 1,000, we're simply going to say that there is only one sig fig. If we see the number 20, there is only one sig fig. Okay? See, look at this. Go back to 1,000. May contain from 1 to 4 significant figures, depending on the precision of the measurement. But in this book, it'll be assumed that measurements like this have one sig fig. So, like I said, I'm trying to make it simple. Next, we get to addition, subtraction, multiplication. Okay. When you add or subtract decimals, okay, your answer should reflect the number of decimal points. For instance, looking at the example up here, 97.3 plus 5.85. So 97.3 plus 5.85. What's the smallest number of decimal points or positions we have? Decimal values. Uno, right? So because there's the smallest number of decimal values is 1, our answer must have only 1 decimal value. So as you see here, when we add them up, we get 103.15. So we can only have 1 decimal point or decimal value, so we round it to 103.2. Multiplication, you simply report your answer in terms of the lowest number of sig figs that were in the problem itself. So we have 123 multiplied by 5.35. And we get an answer of 658.05. What's the smallest number of significant figures do we have in the numbers that we use to calculate? 3. Okay? 123 has 3, 5.35 has 3. So we must report our answers in terms of 3, so you get 658. Questions on our rules so far? Again, they really haven't changed at all from previous times you've been in here.
So just like zeros that, like in numbers that aren't decimals, like like if it's like a number that's not zero and then zeros, the zeros are not significant.
Do you have an example in mind so I can try to follow there?
Like 2,000.
2,000. Okay. Yes. Since there is not the almighty decimal point, then you, in our situation, we will only put one sig fig.
Gotcha.
Okay. Never.
It was like 1,000.0.
1,000.0. Count them. Be 5. Yeah, because of the 0.0. Yep. Any other questions regarding this? Now I'm just going to briefly mention something that I'm not even going to worry about. Okay. Who here has ever rounded a number in their life? Hopefully all of you. What was your general rule when rounding? Below 5, you round down. Above 5 or above, you round up, right? Well, that's what we're going to do in here. But, you know, the book says when you round down, yes, whenever the digit following the last significant figure is a 0, 1, 2, 3, or 4, you can round down. Or if the last significant figure is an even number and the next digit is a 5 with no other non-zero digits, and you're standing on your toe and there's snow falling on the ground. That's too much. That's too much. Right?
Yeah.
Way too much. Yes. We are not going to follow their rounding rules. Below 5, round down. Above 5, round up. Capiche? There you go. All right. So that actually leads us into section 3. Whereas, don't forget, tomorrow we're going to have a quiz review. I got some questions made up. We're still talking about this today. So it looks like we're going to most likely finish section 3 tomorrow in class. Okay. Now, actually, we can probably get through this. Okay, it's a pretty short section. Interpret data in tables and graphs. Distinguish between conventions for abbreviating units of quantities. Use dimensional analysis. Actually, now that I see dimensional analysis, I forgot that was in there. I will probably have to continue this. Okay. Form order of magnitude calculations. Now, we don't ever do order of magnitude calculations. I think it's pretty simple. But in your homework, I can't remember if your homework is due tomorrow or not, or tonight, I can't remember. But it's completely doable if we don't get finished here. Okay? But there is a question, and I threw it in there just because it's a fun question, and I think it's an easy point. So, we have a few minutes left. Okay. So if we look at page 21 in your textbook, go ahead and put 21 in your text. Open your textbook, page 21. So all the time, one of the premises of this section is looking at tables and graphs and equations. Okay. Now we talked about in the second section yesterday. We talked about Galileo's thought experiment with the bricks and who fell faster. One thing I didn't mention was the fact that Galileo's thought experiment actually does work in a vacuum. Okay. Because on Earth, the larger an object is, the more friction it's going to build up on itself as it falls. So a lot of times you're going to see, as you go through this book, you're going to see that a lot of things are not included, okay, or dismissed. Now looking at that experiment, you'll see table tennis ball and a golf ball are dropped in a vacuum. Okay, obviously if you've ever held ping pong, I should say, and a golf ball, there is a significant difference in their mass, okay, but similar size. So they're dropped in a vacuum. The results are recorded as a set of numbers corresponding to the lines of the fall and the distance each ball falls. And a convenient way to show this is on the next slide. It's a table. Okay. You can see as you look through here, as time progresses, you start seeing the distance the golf ball falls and the distance the table tennis or ping pong ball falls, okay, in terms of centimeters. But trying to compare numbers back and forth, back and forth, back and forth can be somewhat daunting, especially if you have an experiment with thousands of data points. Okay? So, another way to do this is to transfer this data into a graph. Okay? So, graphs can show relationships between objects. They can show the data of objects. Okay? As you see here, this graph, as time goes on, as time increases, so does our distance. Okay? That means that the objects are beginning to accelerate. Okay? And so, graphing will be a part of labs and everything this year. Okay, we're going to finish. Equations, okay? Obviously, you really haven't had to do anything with equations yet. Okay, you will. But remember, when we're talking about variables, okay, that variables are going to be letters that are either bold-faced or italicized. Okay, so whenever you are doing formulas or you are reading problems, typically the variables and other specific quantities will be bold-faced or italicized. Units, like SI units, are going to be abbreviated simply with Roman letters. Okay, and we're typically going to use for conversions, dimensional analysis. You can also use order of magnitude. Okay. Yeah, we don't have time to finish this one. So what I'll probably do is do a really short video on this slide, maybe go back a slide. And then that'll be it, and then we'll do the review. So make sure that you watch the video tomorrow of the review, because your quiz will be online